All right, today we're going to talk about factoring by grouping, but before we do that, it's really important for you to understand a greatest common factor. So looking at part A, you have to ask yourself, now there's a 1 here. What's the biggest number that goes into 1, 4, and 3? And really it's just a 1, and if it's just a 1, we don't write anything down for that. And then you have to ask, do they have any x's in common? And if so, how many do they have in common? So this one has 3 of the x's, 1 of the x's, and 2 of the x's. So altogether they have just one x in common. Then you want to divide that out. So x cubed, and this is to the first, x cubed divided by x to the first, you would subtract exponents x squared. Bring down the plus 4. X divided by x would cancel out. Goodbye. Bring down the plus 3, and x squared divided by x, you would subtract exponents, and we have x to the first right there. Now there's a long way of doing this too. I'm just going through it the normal way, but there's a longer way to find GCF. Let's go over here and look at this. The biggest number that goes into 2 and 10 evenly is 2, and they don't have any x's in common. So 2x to the 9th divided by 2 would be 1x to the 9th. Do you have to write the 1? No, but who cares? Not a big deal. Bring down the minus. 10 divided by 2 is 5. And there you go. Now, we have to know that to be able to do this stuff, which is factoring by grouping. And I want to tell you right now, if I go too fast, make sure you pause the video, or you can go back and you can rewatch. It's always a good idea to just watch the video at first, and then the second time through, maybe do the problems, okay? So I'm just giving you some tips. So when we factor each polynomial completely, here's what you're going to do. You're going to look at only these two terms right now. So just look at these two and tell me what the GCF is. And the GCF between those two is an x squared. They have an x squared in common. And you're going to factor an x squared out of those two. So x cubed divided by x squared, if you subtract exponents, that's x to the first. Do you need to write the little one on the x to the first? No. But if you do, no one's going to arrest you. It's okay. And then bring down the minus. X squared divided by x squared is 1. Then we're going to do that with this right here. And you want to always use the symbol that is in front. So if there's a plus here, bring down a plus. Now the GCF between these two, there's nothing, right? Just a 1. So if that happens, just write that 1 there. And if we divide both of these by a positive 1, nothing changes. Nothing changes at all. Now here's what I want you to do, and this is where some students get really confused. So if you look at this and you look at this, what is the big, huge thing that they both have? They both have a big, huge thing in common. And hopefully you can see that the big thing that they both have in common is this x minus 1. This x minus 1. They both have that in common. So you're going to factor that out. It's just an enormous GCF. It's the same kind of deal. So if I have this and I factor the x minus 1 out, what I have left over is an x squared. And if I have this and I factor an x minus 1 out, what I have left over is just that plus 1. And then this is as far as you can go. You can't factor this any further. Sometimes, if there was a minus here, we could do difference of squares, but you can't go any further with that. Let's go over here. So the GCF between these two is going to be an x squared. And if we factor that out of there, x cubed divided by x squared is x. Bring down the minus, and 2x squared divided by x squared is just this 2. Remember what I said about the signs. Whatever sign is here, that's what you want to bring down. And then the GCF between 9 and 18 would be 9. So negative 9x divided by negative 9 is x, and positive 18 divided by negative 9, and be careful here, positive 18 divided by negative 9 is negative 2. Now, if we look at these two terms, look at these two terms right here. Those are your two separate terms. What big, huge thing do they have in common? It's just an enormous thing. You should see that they both have an x minus 2 in common. So if we factor that x minus 2 out, imagine it's leaving. We're factoring it out. We're pulling it out of there. We would have an x squared minus 9 left over. See how that's what's left over? Now let's talk a little bit, because you can go further with x squared minus 9. Don't forget that the difference of squares, it's a shortcut, says a squared minus b squared is a plus b, a minus b. In other words, let me do another example here. If I have x squared minus 16, this would be x and x plus and minus, and the square root of 16 is 4. Okay, so when we look at x squared minus 9, let's bring this down. We can factor this further. X plus minus, and the square root of 9 is 3. So make sure you go all the way when you do these. Here's the next one. So our GCF between these two here is a 4x squared. So if we divide 4x cubed by 4x squared, we get x. 8 divided by 4 is 2, x squared divided by x squared is 1, so that cancels. Make sure you bring down this plus here. The GCF here would be a 6, and if I divide both of these by 6, we have an x plus 2. So looking at these then, this term and this term, the big huge thing that they both have in common is the x plus 2. So we would take that x plus 2 out, we would factor it out, and then what's left over is this 4x squared plus 6. Now, I did not pull out a GCF in the beginning out of everything, so be careful. You should pull a GCF out of everything to begin with, but if you didn't, you'd be stuck in this situation. You do want to look at this. Do you see that there's a GCF of 2 in here? So I'm going to bring down my x plus 2. I'm going to factor this 2 out of here, and if I divide both of these by 2, I have 2x squared plus 3. Now this is an awkward way of leaving the answer. Many times you'll see the answer written like this, but quite honestly, it doesn't matter how you leave your answer. Both of these would be correct. It's just that you'll see this more often. Okay, so make sure you go all the way with it. There's nothing else we could do to factor here. So looking at this, the GCF between these two is an x squared. And then what would be left over is a 3x minus 2. And then here, bringing down the negative, the GCF between those two is 3. And when I divide both of those by 3, I have 3x, and be careful here, minus 2. Again, if I look at this term and I look at this term, the big huge thing they have in common is the 3x minus 2. So I write down the 3x minus 2, and then my leftovers is x squared minus 3. Now you can't go further with this like we did up here. This was a perfect square, 16 was a perfect square, but 3 is not a perfect square, so that is as far as you can go with that. And that takes care of that. If you have any questions, go back and rewatch that video or ask your teacher. Until next time.